Now, in this video, we're going to learn how to find the range of a quadratic function. Now, this is the only video I'm going to be doing on this because it's so easy. I don't think you will need any more videos uh, on me explaining to you how to find the range of a quadratic function. If you do, however, just leave it in the comments below and I can do more videos, but this probably will suffice. So, this function here, I took it from this past paper question. 2012, paper 11, question 10, part 2. The function g is defined by g of x is equal to 4x squared minus 24x plus 11, and this is the restricted domain. X is less than or equal to 1. State the range of g. Now, the simplest method of this is sketch the graph. This is a quadratic function. In my previous videos, I did an entire playlist on how to sketch quadratic functions, how to sketch a parabola. So the first thing you want to do really quickly is to complete the square, and that's what you get when you complete the square. So you know that the vertex of this graph is going to be 3, negative 25. That's going to be the vertex of this graph. And you know that this graph is a happy graph, so it's going to look like this. It's going to look something like that, and you can solve this quadratic expression as a quadratic equation, set that to 0 to get where the graph intersects, the x-axis. So you can sketch this graph and whatnot, but I have the graph sketched here on desmos.com/calculator, which again is a graphing website that you can use to sketch graphs. So credit to Desmos, it's a very good website. You can sketch your graphs on there, and you can see our graph is going to look like this. You can zoom it out, you can zoom it in. This is your 0.5, this is your 5.5. So now that you have your graph sketched, you're trying to find the range of this function. And remember, finding the range of a function is basically meaning what can be the possible values of g. What are the possible g values if x is less than or equal to 1, because this is the domain. X is less than or equal to 1. So we're going to go to our function and we are going to go to x is equal to 1. Well, when x is equal to 1, our g of x is equal to negative 9. When x is equal to 1, our g of x is equal to negative 9. Just plug that in the calculator. Plug in 1 here. 4 multiplied by 1 squared minus 24 times 1 plus 11. That's going to be 4 minus 24 plus 11, which indeed is negative 9. So if the domain for this function is x is less than or equal to 1, it means you're ignoring all the x values that are to the right side of the 1, which means your graph starts here and then it goes like this. It means that the rest of the graph, which is to the right, which is this entire part, we are cutting it out. We are ignoring it because we want our x to start at 1. And if x is less than or equal to 1, means we're going to this side, and if we're going to this side, we are going upwards on the graph. We are following the graph this way. So your graph, what's going to be the range? What would be the possible y values if you go like this? Well, what would be the possible g values if you go like this? Well, it would be g of x is greater than or equal to negative 9. G of x is greater than or equal to negative 9. G of x is greater than or equal to negative 9. It will be g of x is greater than or equal to negative 9. Because when x is 1, g is 9. Now when x is less than 1, if you go to the less than 1, you're moving upwards on the graph, which means all your g values, all your y values are going to be greater than negative 9 because you're moving upwards. You're going to be going to values that are greater than negative 9. So it'll be g of x is greater than or equal to negative 9 because you're going upwards on the graph, and when you go upwards on this part of the graph, your y values will always be greater than or equal to negative 9. They'll always be equal to or greater than negative 9. So let's actually confirm this from the mark scheme. And there we go. G of x is greater than or equal to negative 9. g of x is greater than or equal to -9. The vertex, please ignore this. They're being lenient, it's greater than or equal to. Some examiners will not penalize you, but some won't give you the mark if you don't put the or equal to sign. They are just being lenient. They are just being lenient here, but the true and correct answer is g of x is greater than or equal to -9. And that's how you find the range of a quadratic function. You look at the graph, and then you do this analysis here. Until next time.